Chinese robotic spacecraft have been operating directly on the moon's surface for several years now. They've taken a leading position among automated explorers and have been systematically surveying mysterious areas that humanity once could only speculate about. Every year, these systems make new discoveries and deliver samples of lunar dust and rock back to Earth, where the material is then examined in detail in laboratories. And it's within these samples that Chinese scientists notice something that could change not only how we think about the moon, but potentially affect the future of life on Earth as well. The paradox of the moon is that the deeper we try to read it, the more mysterious it becomes. Earth itself is a strange planet, not only because life exists here, but because it behaves in ways that other rocky worlds in the inner solar system simply don't. And to a large extent, our big gray companion, the moon, is responsible for that. To understand the contrast, you only have to look at Venus. In size and mass, it's almost Earth's twin, but it has no moon at all. Mars also resembles Earth in certain ways, although it's significantly smaller. Technically, it has two moons, but both are so tiny that their scale is almost surprising. The larger one is only about 22 kilometers across, and the smaller one is around 12 kilometers. In other words, both of them could easily fit inside Moscow, meaning they're smaller than the span of a major metropolitan area. Gas giants, by contrast, are surrounded by large moons, but those planets themselves are enormous. Jupiter, for example, is 318 times more massive than Earth, 318, and yet its moons are roughly comparable in size to our moon. That pattern looks unusual, and scientists are still trying to explain why Earth ended up in such a strange situation. That's exactly why the moon continues to be studied so intensely. When NASA sent astronauts to the lunar surface in the 1960s, they returned with a substantial amount of rocks and dust. And the first thing that truly shocked researchers was this. Lunar rocks turned out to be almost identical to Earth rocks. That was unexpected, because if Earth and the moon had formed independently, the raw material that built them should look noticeably different. Usually, people assume that a planet and its moon are two separate bodies that later end up in an orbital relationship. But if Earth and the moon are so similar, then most likely they formed in the same place and at the same time. And that raised the key question: what exactly was the mechanism? After the Apollo missions, the dominant hypothesis took shape. Earth collided with a wandering planet roughly the size of Mars, often described as a rogue planet, about a few 100 million years after the solar system formed. Different versions of that impact scenario were debated for decades, but only relatively recently were scientists able to model it in detail using a supercomputer. The system ran millions of simulations until it produced a result that matched what we know about Earth and the moon as closely as possible. This modeling outcome is what's commonly referred to as the giant impact. The energy of the collision melted both worlds. The force of the impact blasted an enormous fragment of Earth into space, while most of the rogue planet was absorbed by Earth and sank down toward Earth's core. In that framework, the moon became a kind of mini-Earth, a piece torn away by catastrophe that later cooled and turned into a rocky satellite. But despite all the similarities, the moon is still very different from Earth. And even though this theory is considered the leading one, it remains unproven, which means that studying the moon's origin directly helps us understand the history of our own planet. Over the last 5 years, China has effectively been leading lunar exploration. The country is investing major resources and sending robots in search of answers to long-standing mysteries. The greatest focus of China's program is the far side of the moon. China was the first in history to reach that hemisphere, and later even managed to deliver samples from it, materials that are now being studied on Earth. And despite the popular phrase, the dark side of the moon, the far side is illuminated just as well as the near side. It simply never turns to face Earth. In theory, both hemispheres should be similar, but in reality, they aren't. Paradoxically, it's the side we see that looks darker because the familiar face of the moon is covered with huge dark lava plains, ancient floods of volcanic lava. On the far side, there are almost no such patches. There, the surface is mostly light gray and shredded by countless impact craters. The difference between the two sides is obvious, but its cause remained unclear for a long time. The Chang'e-4 mission, which landed on the far side in January 2019, became the first spacecraft ever to operate in that region. It deployed the U-2 rover, which began studying an area near the giant von Karman crater, about 180 kilometers wide, roughly comparable to the length of Cuba. This crater lies within the massive South Pole, Aitken Basin. It's about 4 billion years old, and its diameter reaches around 2,500 kilometers, nearly the width of India. Scientists were especially interested because the asteroid that created this basin punched through the moon's crust by roughly 13 kilometers, exposing deep mantle rocks, the layer between the crust and the core. And it was there, according to researchers, that the most important secrets could be hiding. And indeed, U-2 recorded rocks that researchers believe originated in the moon's mantle. Before that, nothing like it had ever been brought back, neither by Apollo astronauts nor by Soviet robotic stations. This discovery immediately drew attention, and interest in further expeditions only intensified. In December 2021, U-2 photographed a strange object on the horizon that looked almost cube-shaped. The shape seemed so unusual that the story instantly exploded across the media. At first, some people even compared it to the monolith from Stanley Kubrick's Space Odyssey. Later, however, it became clear that it was simply a rock, made to look like a cube by perspective, lighting, and the pixelation of the camera image. But that very incident only increased public interest in lunar missions. And then, in 2024, China returned to the far side again with Chang'e-6. The spacecraft collected new samples and delivered them to Earth. For the first time in history, material from the moon's far hemisphere ended up in human hands. Analysis showed that these rocks are noticeably different from those collected on the near side. They are lighter in color, denser, and more deep origin in character, with a higher content of clumped, blocky structures. Yet at the same time, they contain fewer volcanic rocks. There was less lava material than scientists expected to see. One of the fragments is 4.2 billion years old, the oldest lunar rock known today. But there are also rocks around 2.8 billion years old, younger than many Apollo samples. That pattern suggests that the moon remained hot and partially molten for much longer than the giant impact theory had assumed. After all, the moon is much smaller than Earth and, logically, should have cooled faster, especially on its far side. The new data contradicts that expectation. This brings attention back again to the near side. For a long time, our entire knowledge base about the moon was built on the very limited Apollo missions, which could land only in relatively flat equatorial regions. Even if you include the rover routes, the total area explored was about 25 square kilometers. That's 1/5 of Sakhalin, meaning it's extremely little. Sakhalin is a large island. 1/5 of it is still a huge territory compared to what Apollo actually covered. China's missions have significantly expanded scientists' understanding. Chang'e-5 was the first mission since the 1970s to return samples from the lunar surface, and it was able to choose a truly interesting site, Mons Rumker, a volcanic region in the northwest of the moon's near side. Lunar volcanoes don't behave like Earth's. They don't erupt explosively. Instead, they quietly and steadily pour out lava for long periods, forming broad, flat structures. And the sample found there turned out to be the youngest ever brought to Earth, about 2 billion years old. In addition, Chinese researchers reported a new mineral, change site, a transparent crystal smaller than the width of a human hair, yet containing an extremely rare isotope, helium-3. This element could become an ideal fuel for future nuclear fusion reactors, systems that could provide humanity with nearly endless clean energy without radioactive waste. On Earth, helium-3 is almost non-existent because the solar wind is blocked by Earth's magnetic field, while the moon lacks that kind of protection. At the same time, the practical value of helium-3 will only become real once working fusion power plants actually exist. But something else turned out to be even more immediately significant. Chang'e-5 discovered water on the moon, not just atoms of hydrogen and oxygen, but full H2O molecules, H2O, trapped inside a mineral called ULM-1, which is a hydrated salt. This means water, although bound within minerals, may occur virtually everywhere on the moon. not only inside permanently shadowed craters as previously believed. And if water isn't rare, then building lunar bases becomes far more realistic. All of this is part of China's larger goal, not only to unravel the moon's past, but also to prepare it for a future human presence. In essence, robots are laying the groundwork for future bases. NASA, in its time, simply landed people for a few days, but long-term habitation requires a deep understanding of the environment. Right now, China is leading the world's lunar program, and its missions are, quite literally, opening a new chapter in the history of space exploration. Dear viewers, what do you think about this story? Please write your thoughts in the comments. If you enjoyed this video, hit like and subscribe to our channel. See you next time.